Here we have an absolute value equation. Our first step is now going to be to isolate the absolute values. So we want to move everything else to the other side. We're going to start by adding 2 to both sides. This gives us 5 times the absolute value of x plus 9, equal to 2. We can then divide both sides by 5 to get the absolute value of x plus 9 equal to 2 over 5. At this point, it's important to realize that what has an absolute value of 2.5? Well, 2 over 5 has an absolute value of 2 over 5. I can then subtract 9 from both sides and get that x is equal to negative 43 over 5. However, that's not the only thing that has an absolute value of 2 over 5. The absolute value of negative 2 over 5 is also 2 over 5. So we have a second equation. X plus 9 equal to negative 2 over 5. We can subtract 9 from both sides, and this time we have x equal to negative 47 over 5. And there's my second answer. Absolute values should always have 2 answers because the absolute value of a number is the same thing as the absolute value of its negative. So make sure to set the equation equal to the number as well as the negative of that number. Here we have an inequality. Negative 4 over 5x is less than or equal to negative 6 over 7. We need to solve for x, so we need to get rid of the number in front of x. We can start by multiplying by the denominator on the left, which is 5. This gives us a negative 4x on the left, and then the right would turn into a negative 30 over 7, since 6 times 5 is 30. We can then divide both sides by negative 4. Remember, dividing by a negative number flips my inequality, and if I try to think what this is, negative 30 over 7, dividing by a number is the same thing as multiplying by its reciprocal. So whenever I multiply this, I actually get negative 15 over 14. So x is greater than or equal to negative 15 over 14. If we want to write this in interval notation, our number is bigger than this, so it can be anywhere from this to infinity. We always use a parenthesis on infinity, and we're going to use a square bracket on the negative 15 over 14 since it should be included. Here's a slightly more complicated inequality. We need to start by getting all of our variables on one side. In order to do that, I'm going to subtract 3x from both sides. 9 minus 3 would be 6x minus 18 is greater than or equal to negative 42. We can then add 18 to both sides. The left is then a 6x. And then on the right, we have negative 24. Dividing by 6, I get that x is greater than or equal to negative 4. Since x can be bigger than negative 4, in interval notation, this will go from negative 4 to infinity. A parenthesis on infinity and a square bracket on negative 4 since we do include that number. Next, we'll do a little bit of a word problem. If we throw a ball in the air, we'll say the height of the ball after a certain number t of seconds is given by this equation h of t equal to negative 16t squared plus 96t plus 3.2. And we want to know what the height is after 3 seconds. Since that's a time, and t stands for time, all I have to do is change all the t's to 3. So I have negative 16 times 3 squared plus 96 times 3 plus 3.2. And now we can just evaluate this. Doing our multiplications first, I have negative 144 plus 288 plus 3.2. Adding this then gives us a total of 147.2 feet. similar word problem. The average weight given by W of a fish caught in a particular lake is 0.001x cubed plus 0.03x squared plus 1.7, where x is the length of the fish. So we want to know what the average weight of a fish is that's 14 inches long. We know the length, which is x, so we're just going to stick this number in for x. 0.001 times 14 cubed plus 0.03 times 14 squared plus 1.7. Now we need to actually do our multiplications. The first one, 14 squared times 0.001 is 0.196. The next one, oh, sorry, we messed that up. 14 cubed times 0.001 is 2.744 plus 14 squared times 0.03 is 5.88, and then plus 1.7. Now we can just add up these three numbers, and we get 10.324.